In this episode, we're going to be looking at the topic of algebra. In today's lesson, we will write algebraic sentences for problems, express simple sentences and word problems as algebraic expressions, and solve equations. What is algebra? Algebra is a branch of mathematics that substitutes letters for numbers. Algebra is about finding the unknown or putting real-life variables into equations and then solving them. An algebraic expression is a mathematical phrase that can contain ordinary numbers, variables like x or y, and operators like add, subtract, multiply, and divide. Here are some algebraic expressions. A plus 1, a minus b, 3x. If you set an algebraic expression equal to something with an equal sign, you now have an equation. An equation is a mathematical statement in which two things are equal. It consists of two expressions, one on each side of an equal sign. For example, x minus 4 is equal to 10. So we have some number, but we don't know what that number is. And when we take away 4, we are going to get 10. All right. And just off the top of our head, we know that the answer for this would be 14, right? Because if we have 14 and then we take off 4, then we will get 10. So this is a very important point to remember. Algebraic expressions do not have an equal sign, but an equation will have an equal sign. Number sentences. Number sentences are like English sentences except that they use math symbols instead of words. A number sentence may be true or false. For example, the number sentence 14 plus 3 is equal to 17 is true. The number sentence 55 is less than 19 is false. Now here are some symbols. Equal, it means is equal to, the equal sign with a slash through it, is not equal to. And then we have the alligator mouth that is open to the left, that is less than, and the alligator mouth that is open to the right, that is greater than. Now let's look at solving equations. What is missing? There is something and we take away 2 from it and then we end up with 4. Okay, the answer is 6, right? Because 6 minus 2 is 4. Easy stuff. Well, in algebra, we don't use blank boxes. We use a letter, usually an X or Y, but any other letter is fine. So we write X minus 2 is equal to 4. It is really that simple. The letter, in this case an X, just means we don't know this yet and is often called the unknown or the variable. And when we solve it, we write X is equal to 6 because now we know what it is. All right. Algebra is just like a puzzle where we start with something like X minus 2 is equal to 4 and we want to end up with something like x is equal to 6. But instead of saying obviously x is equal to 6, use this neat step-by-step approach. Work out what is to be removed to get x. Remove it by doing the opposite. Adding is the opposite of subtracting, and do that to both sides. So let's look. Here is an example. We want to remove the minus 2. Here it is, x minus 2 is equal to 4. We want to remove this. To remove it, do the opposite. In this case, you're going to add 2. So minus 2 plus 2 is going to be equal to 0. do it to both sides. So x minus 2 plus 2 on this side is equal to 4 plus 2. So we add 2 to this side and we add 2 to this side. Now, let me explain a little what's happening here. A minus 2 means that you owe 2. A plus 2 means that you have 2 to give. So if I have 2 to give and I owe you 2, when I give you the 2 that I owe you, how many will I have left? None. Alright, so that's simply what the minus 2 means. Whenever we see a minus, it means that it's a negative. We owe that. But when we have the plus, it means that it's a positive, and that is what we have. Another thing about these signs, even if you don't see the plus sign, it's usually there for certain numbers. Like this would be a positive 2. All right, I'm hoping you understand that part of it, that it is implied that this is a positive 2. Unless you see the negative, then all other numbers are going to be positive numbers. But we'll get to that in a later lesson, all right? Which is x plus 0 is equal to 6. Now, anything plus 0 is the same thing, right? So we could say x is equal to 6, and this is solved. Now, there's a certain thing about balance that we will come to. And here we go. Why did we add 2 to both sides? To keep the balance. So on this side, we had x minus 2 equal 4. We're going to add 2 to the left side. If we add 2 to the left side, this side becomes out of balance. So we add 2 to the right side also, and then this would be in balance again. So anything that is done to the left hand side of an equation must be done to the right hand side of the equation to maintain balance. Just remember this. To keep the balance, what you do to one side of the equal sign, we should also do to the other side. Now, here are some activities. Number 1, use the following symbols to write 3 number sentences which are true and 3 number sentences which are false. So we have equal, not equal to, less than, and greater than. So you're going to fill those in, and then we will have a look at those. They said we should write 3 number sentences which are true and 3 number sentences which are false, and we are supposed to use these symbols. So the symbols were the equal sign, not equal, less than, and greater than. Okay, so let's go with those that are true on this side and those that are false on this side. So 3 plus 3 is equal to 6. All right, let's do one with not equal. 7 is not equal to 8. This is true. Then we have 21 is less than 40, and 50 is greater than 25. Let's go now with those that are false. So 3 plus 4 is equal to 6, and this is incorrect because 3 and 4 would make 7, and 3 plus 3 is not equal to 6. That is true because 3 and 3 would make 6. So if we're saying it's not equal, then that is false. Let's go with one that is less than 81 is less than 70. This is going to be false because 80 is greater than 70. Let's go with greater than. And 25 is greater than 60. This is also incorrect because 60 is actually greater than 25. Now, in grade 1, they usually teach children when writing these signs, the greater than, less than sign, that you are going to place, they have this saying, alligator mouth nyam enough, right? And it means that you're going to place the open end of this sign to the what? The number of greatest value. That only occurs when we are making something true or when we are writing it correctly. It does not apply when we're, having a false statement. Let's look at this. 21 is less than 40, and that is true. So it opens to the greater value. Let's look at this. 50 is greater than 25, and that also is true. But look at these two. 80 is less than 70, and that is not true. Okay? And 25 is greater than 60. That is not true. So that idea of alligator mouth nyam enough, a lot of you may have that in your minds still, and it may not apply correctly in every situation because it only works when what you are looking for is true. Number 2, complete the following table by writing suitable expressions. Now here we have phrases and we have expressions. Now remember, once we say expressions, algebraic expressions, we are not going to write anything that includes an equal sign. So this one says the sum of 9 and 8. So here we have 9 and 8. And we have 9 plus 8. And this is the sum of 9 and 8. Now remember that we're talking about what? Expressions. So if it is an expression, then we have no equal sign. So there's no equal sign in this. The product of a number and 6. Okay, so product means to what? Multiply. So some number, we can call that number n, and 6. Okay, so this is some number and 6, some number multiplied by 6, or we could say 6n. Okay, remember that we could use any letter. I am using n. We could use x, it would be the same thing, 6x. We could use y, 6y. So this is the what? Product of 6 and y. 3 times a number decreased by 11. So it's 3 times some number, and I'm going to decrease. Now decrease in mathematics means to what? To take away. So I have 3 times n, and then I'm going to decrease it or take away 11. 5 more than twice a number. Now 5 more means we're going to add 5 to twice a number, and twice a number would be to what? To multiply the number by 2. So I have twice a number, which is 2n, twice some number, I don't know what a number is, and I'm going to add to that 5. So 5 more than twice a number. Okay, so we could write it like this, or we could say 2n plus 5. The answer would be the same. There is a property of mathematics we call the commutative property that says the order in which we add does not change the sum. For example, if I say 2 plus 3, it's going to be equal to 5, and if I say 3 plus 2, it is still equal to 5. A number decreased by 11. So we would have a number and we would subtract or take away 11, and we need to represent that. So we have some number. I'm going to call my number n minus 11. So I have 32, and I'm going to divide that by a number y. That's one way it could look. 32 divided by y. There's another way that this could look, or I could have 32 fraction bar or vinculum and y. So these are the same things. The 32 here divided by y is the same as the 32 over y. Same thing. Number 3, Jenny earns $30 a day working part-time at a supermarket. Write an algebraic expression to represent the amount of money she earns in D days. So it could look like this now. $30, and we multiply that by D days, and this could be written as 30D. Okay. Number 4, read the following scenario, write and solve each equation. Now equation, we're going to have the equal sign in this. A, Abigail is 6 years older than John. 6 years ago, she was twice as old as he is. How old is each now? So let's call John's age n, and Abigail is going to be 6 years older, so it would be n plus 6. Now 6 years ago, what would be the case? For Abigail, it would be n plus 6, whatever the age is, minus the 6 years. And 6 years ago for John, it would be n minus 6. But it says that Abigail 6 years ago was 2 times that age. So let's put this in bracket, and then we're going to multiply that by 2. Now, please note that whenever we see a bracket and a number just beside it, even though it's not stated here with a multiplication sign, this 2 is going to multiply everything inside the bracket, okay? So it's implied, and it's one of those rules that you just have to know, all right? So let's go with this now. Let's work this part out. So this would be 2 times n, giving us 2n, and 2 times the 6 would give us 12, so we'll keep the sign minus 12, and this would be equal to this. Now we have n plus 6 minus 6 being equal to 2n minus 6. All right, so let's go a little further. Let's see how we can work on this side. Plus 6 means I have 6 things, and minus 6 means that I need to give away 6 things. So if I have 6 and I give away 6, then I will have none left. So these two will cancel each other. I'll be left with n on this side, and this will be 2n minus 12. Now I'm going to try to get rid of this number 12. If I have 12 here, I am going to add 12 to this, so that again I owe 12 and I give away 12, and I have none of those left. But remember, if I do this on one side, if I add 12 on the right hand side here, I need to add 12 here as well. Okay, so now it would look like this: n plus 12 is equal to 2n. Now I'm going to try to get rid of the n on this side. So I have n here, so I need to subtract this n. Okay, so I need to subtract this n here, and if I subtract n from this side, I need to subtract n from this side. So if I take away the n here, I'm going to need to take away n from this side. This is the same as saying this is 2n, because this is n plus n, and if I take out 1, then I'm going to have 1 left. So this will be 12 being equal to n. All right, or we could put it like this: n plus 12 is equal to 2n. I could say we're going to take away n here, so this will be nothing there. Okay, and then here, if I take away n on that side, I need to take away n on this side, And if I have 2 of them and I take out 1, I will have 1 left. I don't say 1n, I'll just say n. So we could rewrite this now as 12 is equal to n, and that's what we have here. Okay, so it means that wherever we see n in the original statement, we can put 12. Okay, so if we were to do that, then let's switch colors here. Let's get red. So I could now say 12, and we have 12, and we could add the 6 to it. So at present, Abigail would be 18 and John would be 12. That's now. Okay, that's now. So what would the age be 6 years ago? If Abigail is 18, as we showed before, and John is 12 now, then 6 years ago she would be what she is now minus the 6. That would give us 12, and John would have been 12 years old minus the 6, so he would have been 6 years old. So 6 years ago she would have been 12 years and he would have been 6 years old. And this makes our statement true because in the question it said 6 years ago she was twice as old as John. Now 12 is twice as much as 6, so we know that our answer is correct. Finally, B. There are 2 numbers whose sum is 72. One number is twice the other. What are the numbers? So we have 2 numbers. A plus B is equal to 72. Now it says one number is twice the other. So if we have A plus B 72, one is twice the other. So this number must be 2A. Alright, this equals to 72. So if we have whatever B is, it is twice that. So now this would give us 3, because if we have 2A here plus A, this is really 3A being equal to 72. We divide this side by 3 and we divide this side by 3. So let's go. A will be equal to 3 into 72. 3 into 7. Alright, so let's put 72 here and say 3 into 72. 3 into 7 will go 2 whole times. This will be 6. Subtract, we have 1. Bring this down, we have 12. And 3 into 12 would go 4. 4 3s would give us 12. And we'll be done here. So 3 into 72 would go 24 times. So let's look at what this is. So if A plus 2A is equal to 72, this is 24 plus 2 times 24 will give us the 72. Let's look at what this number is. This would be 24 plus 24 times 2, and this would be 48 plus 48 should be equal to 72. So let's go with 48 plus 24, 4 and 8, that would give us 12, right? 2 carry 1, and 1 and 4 would be 5. 5 and 2 would give us 7. So this is correct. So on this side we have 72 being equal to 72, and once we get both sides being equal, then we know that we are correct. So if it is that we had A and let us call the other number B, but B is really 2 times A, then we know that A, one number would be 24 and the other number would be 48. In this episode we were looking at algebra. Algebra is that branch of mathematics that deals with substituting letters for numbers. And we had a couple activities here and we were told how to solve these things step by step. Please remember the difference between an equation and an expression. In the equation, we are going to have an equal sign, but in an expression, we have no equal sign. In an equation, we have expressions on both sides of the equal sign. Alright guys, complete your activities as best as possible, turn them into your teachers, and also go to your textbooks and continue working on algebra. Take care, and I'll see you in the next episode.